Take a look at this example. Determine Vx using nodal analysis. You have to consider the step in order to solve the nodal. For the first step, which is how many loops? So it seems that in this circuit, there is 2 loops, which is this is the first loop, and then this is the second loop. And you have to assign the loop currents for the first loop and the second loop. So I choose I1 and I2. So we already done the first step, which is the first step is to assign loop for each meshes in clockwise. Actually, you can choose in anti-clockwise, but it's easy by choosing the loop in clockwise. So first step is assign loop, assigns loop clockwise. And for the second step, which is decide the numbers of equation. How many equations? Numbers of equation. Because of this circuit consists of 2 loops without dependent source, without any supermesh. So the number equation is depends on the numbers of loop. Numbers of KVL equation will be equal to numbers of loop. So it seems that numbers of loops is 2. So it means that the numbers of equation will be 2. So number of equation is 2 equal 2. As for the third step, so apply KVL for each mesh in the circuit. So from the circuit, you are trying to write down the KVL equation for the first meshes or for the first loop. You can see that this is the elements that related to the first loop, which is I1. So I1 will flow through the 10 volt, 5 volt, and 10 ohm. This is a closed path for the first loop. And you can see that at 10 ohm, there is I2 that flowing through the 10 ohm in a opposite direction. This is the directions of the I1, and then this is the directions of I2. So from the first loop, KVL at loop 1 or at I1. So assume all is positive because of the I1's loop. So the dominance of the polarity will depend on the I1. So minus 10 plus with 5 times with I1, which is this is the Ohm's law. And then the next will be tens. And you can see that there is 2 currents that flowing through the 10 ohm resistor, which is I1 and I2. because of the dominance in the first loop is I1, we consider that the I1 minus I2. So there is no other elements in that loop. It must be equal to 0. This is very important. If you not write the 0, this equation is not the KVL equation. And then for the second loop, KVL at loop 2 or I2. So the polarity for this one will be, so this is the elements that related to the I2. We consider that the I2 is dominant, so the polarity will be like this one. In clockwise, the equation will be, we'll start with the 10 ohm here. 10 times with I2, the I2 is dominant, plus with 10, and you can see that there is I2 and also I1 that flowing through the 10 ohm. So the I2 is dominant, so I2 minus I1 equal to 0. As you can see that if I1 is dominant, so I1 will be subtracts the other currents at the next loop. Same as second equation, so I2 is dominant, so I2 will subtract the other currents at the other loop. So now, this is the equation for the mesh 2 equation. So this is the first equation, and then this is the second equation. Then you can solve this one. So from 1, 5I1 plus with 10I1 minus 10I2 equal to 10. Group the I1 and I2. So I1 is equal to 5 plus 10 minus I2, 10 equal to 0. So it will become equation number 3. So from equation 2, I1 minus 10 plus with I2, 10 plus 10 equal to 0. So I1 minus 10 plus I2, 20 equal to 0. This equation will become the equation number 4. Then rearrange the equations to the metric form. So here is 15. 15 minus 10 minus 10, 20. And then use calculator. The answer for the first one will be I1 is equal to 1 M. And for the I2, the answer will be 0.5 M. So I'm using a calculator's FX 570 ES plus, and I choose the modes 5 for the equation, and then I select equations number 1. So the question will be finding the Vx. By using the ohms law, you can see that Vx is equal to the voltage at 10 ohm. As you can see that by using the ohms law, so I2 times width R 10 ohm. So I2 is 0.5 times width 10. So that will be 5 volt. Thank you.